Boys and girls, this is Mr. Manise here again with another cool video, and in this video I'm going to walk you through how to do each of the Chapter 1 book review problems for sections 1.2, 1.3, and 1.4. So my disclaimer as always is please don't come to these videos and just copy down my answers. I'd like for you guys to work through the problems first, and then come back and watch the video and make sure you've checked your answers or clear up any misunderstandings that you have with these problems. So we have exited the land of quadratics. So I thought I would put this little GIF up on the screen because this is probably what you guys are experiencing right now. And thank goodness we have gotten out of the hardest unit of the entire year. We've left the world of quadratics and now we're moving on to the easiest part of the curriculum. So hopefully you guys are pretty happy about that. So let's go ahead and jump right in. So I have assigned book problems 5 through 22 in the book. So we'll start here with number 5. And number 5 says the instructions say find a pattern for each sequence, determine the pattern, and use it to show the next two terms. Okay, so I'm looking at, I've got 1,000 and then 100 and then 10, and so I've got to figure out what's happening here with these numbers. Well, one way to think about it is just visually what's happening here. That's got 3 zeros, that has 2 zeros, that has 1 0, so the next one I'm not going to have any zeros. So that should be 1. Or the other way to think about it is how do I get from 1,000 to 100? I'm just dividing by 10 every time. 1,000 divided by 10 is 100, 100 divided by 10 is 10, 10 divided by 10 is 1. And the next term, if I divide 1 by 10, the next term will actually be 0.1. 1 divided by 10 is 1/10, or 0.1. Number 6, I have 5, -5, 5, -5. Well, that's pretty easy. I'm just going back and forth between positive, negative. So, of course, the next two terms are going to be 5 and then another -5. Okay, so number 7, we have 34, 27, 20, 13, etc., etc. How do I go from, the way I look at these sequences is how do I go from the first term to the next term? What am I doing? So it's almost like I just cover up those terms. How do I get from 34 to 27? Am I multiplying? Am I dividing? In this case, I'm subtracting 7. Okay, so let's take that hypothesis and let's see if it's true for the next one. 20 minus 7 is 20. Yeah, that looks good. 20 minus 7 is 13. Yeah, so I'm subtracting 7 every time. So if I subtract 7 from 13, the next term is going to be 6. If I subtract 7 from 6, that will give me -1. Okay, number 8, I have 6, 24, 96, 384. Okay, so once again, let's just kind of look at the first two terms. How do I get from 6 to 24? Well, I'm adding 18, right? I can add 18. All right, so now let's look at the next one. 24 plus 18 is 34 plus 8, that's 42. Whoops, that doesn't work. What's another way I can get from 6 to 24? All right, multiply by 4. Okay, let's check that out. If I multiply 24 by 4, yeah, that's 96. If I multiply 96 by 4, yeah, that's 344. So I'm simply multiplying by 4 every time. So if I multiply 344 by 4, that's going to give me 1,536. And if I multiply that by 4, that's going to give me 6,144. Oops. It's kind of hard to get all of this into the camera. Okay, so that's number 8. All right, so let's move on to number 9. Find a counterexample to show that each conjecture is false. The product of any integer and 2 is greater than 2. The product, what does product mean? Okay, product means multiplication. Sum means addition. So what this is saying is if I multiply any two numbers, the product of any two integers just means a whole number on the number line, counting numbers, positive or negative counting numbers basically. And 2, if I multiply any number on the number line times 2, that's going to be greater than 2. Well, if I multiply 4 times 2, yeah, that's greater than 2. If I multiply 0 times 2, that's 0 though, that's not less than 2. What about if I multiply by a negative? Anything times a negative is, any positive number times a negative is going to be negative. So if I multiply 2 times, say, -5, that gives me -10. Well, -10 is not greater than 2. That's less than 2. Okay, so that would be a counterexample. So that's just one of infinite amount of counterexamples. You can multiply 2 times any negative number, times 0, and none of those are going to be greater than 2. Number 10, the city of Portland is in Oregon. So this is a little tricky if maybe you're trying to think of what's a city named Portland that's not in Oregon. Well, this one you might have to Google. So if I just type in Portland, the city of Portland, if I type that into Google, then hopefully what you'll find in your research is there is a Portland, Maine. There are 2 Portlands in the U.S. So that would be a counterexample. It says, whoa, 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 I got another Portland that's not in Oregon. It's located in Maine. Okay, let's move on to these next several problems are under section 1.3 on conditionals. So remember, a conditional is an if-then statement. Got to see the words if and then. So 11 through 14, they're asking us to rewrite each sentence as a conditional statement. Okay, so I simply have to slap in a if and a then. If comes before the hypothesis, the then comes right before the conclusion. So if I have all motorcyclists wear helmets, all motorcyclists wear helmets, how could I put in an if then? I can't say if motorcyclists then wear helmets. That's a sentence fragment. That doesn't make any sense at all. So how could I reword this with an if and a then? If motorcyclist, I could say if you are a motorcyclist. I could say if a person is a motorcyclist. Then I'll just use you. I'll just say if you are a motorcyclist, then, and that's where I'm going to throw in the then I can't say then wear helmets. I got to say then you wear a helmet. So notice, whoops, I'm sorry. I got to remember that you guys can't see this in the camera. Okay, so remember, I'm throwing in an if and I'm throwing in a then, okay? Now, if you guys flip this, if you put the if here and you said if you wear a helmet, then you are a motorcyclist, that's not necessarily true. Okay, so if you wear a helmet, I could be riding a bicycle, I could be riding all kind of stuff. I could be riding a four-wheeler or whatever. So you got to remember to keep what they want you to write as a conditional, keep the sentence the way it is. You just got to somehow figure out a way to put an if in the front and a then in the middle. And you might have to manipulate the statement, and there are lots of different answers with these questions, guys. So there's a lot of times there's no one right answer, correct answer. Okay, number 12 says 2 non-parallel lines intersect in one point. Okay, 2 non-parallel lines intersect in one point. So how can I write that with an if and a then? Now this time I pretty much can just go ahead and throw in an if in the front. I can just say if 2 non-parallel lines intersect. That's okay. If two non-parallel lines intersect, then I can't just say in one point. How could I rewrite the second part? If 2 non-parallel lines intersect, then they gotta meet at a point. I could literally use that, or I could use the word intersect again. How about this? What if I said if 2 non-parallel lines intersect, then they meet or they intersect at one point or in one point. 2 non-parallel lines intersect, then they intersect at one point. Okay, let's go on. Number 13. Angles that form a linear pair. I know it's pronounced linear. The first 4 letters of linear or line. Angles that form a linear pair are supplementary. Angles that form a linear pair are supplementary. So once again, I can't just say if angles that form a linear pair. That doesn't really make sense. What if I said 2 angles? Okay, how about this? If 2 angles form a linear pair, okay, If two angles form a linear pair, then are supplementary. Well, I can't say that, doesn't make sense. Then they, I can say, then they are supplementary. And remember, supplementary just means they add up to 180 degrees. Okay, number 14. School is closed on certain holidays. School is closed on certain holidays. How can I put an if here? If school is closed, then certain holidays. That doesn't make sense. If school is closed, then, I want y'all to think about this for a second. How about if school is closed, then today is a certain holiday? That works. I like that. So let's go with if school is closed, then it is a certain holiday. Okay. All right, so the rest, 15, 16, 17, and 18, they want you to write the converse, the inverse, and the contrapositive given the conditional. Determine the truth value of each statement. Okay, so remember, let's go ahead. I'm just going to go ahead and write this down. Converse. Let's remember how to memorize these. Converse, switch the shoes. Okay. Inverse, put in the knots. Inverse, put in the knots. Contrapositive, I'm going to do both. So I'm going to switch the shoes, switch the hypothesis and the conclusion, and then I'm going to put in the knots. So let's look at number 15 here. So I have if an angle is obtuse, make sure you guys can see this. If an angle is obtuse, then its measure is, I'm going to keep this on the same side, is greater than 90 and less than 180. Okay. All right, so converse. Switch the shoes. So I'm going to switch these two statements. Okay, so the conclusion comes first and the hypothesis comes second. So basically I'm going to switch out the if and the then. I'm just going to reverse these guys. I'm going to say if its measure is greater than 90 and less than 180, then the angle is obtuse. Okay, so if its measure is greater than 90 and less than 180, I'm going to abbreviate a little bit here, then it is an obtuse angle. Or you could say then the angle is obtuse, however you want to word that. Okay, inverse, I've got to put in the knots. So if an angle is not obtuse, then its measure is not greater than 90 and less than 90. Okay, I'm not going to write this out, guys, just for sake of time on the video. I mean, I think you guys know what's going on here if you just understand when to put the knots. So the inverse, again, I'm just going to say this out loud so you can just check your answers. You're going to put in the knots. If an angle is not obtuse, then its measure is not greater than 90 and less than 90. So you leave the original conditional the way it is. You put a knot here and you put a knot here. Okay. Contrapositive, I'm going to do both. Okay. So I'm going to switch the shoes. So basically I'm going to stick with the converse here. I'm going to take the converse and then I'm just going to put in a knot. Okay, so I'll start over here. So if the measure is not greater than 90 and less than 180, then it is not an obtuse angle. So you switch the shoes and then you put in the knots. Okay. All right, number 16. if a figure is a square, then it has 4 sides. Okay, so there's the hypothesis, there's the conclusion. If a figure is a square, then it has 4 sides. Okay, so the converse, I'm going to switch the shoes. I'm just going to switch these two statements. So I'll start here. Basically, I'm just switching the if and the then. So I'll have if it has 4 sides, then the figure is a square. Okay, that's the converse. Switch the shoes. Inverse, I leave everything the way it is. I don't change anything, and I just put in a not. So if a figure is not a square, then it does not have 4 sides. Okay. Contrapositive, I do both. Okay, so I'll start with a conclusion. So once again, I'm basically switching the if and the then, and I'm putting in the nots. So these guys will switch. So it'll look like this. If it does not, I've got to put in the nots. If it does not have 4 sides, then the figure is not a square. Once again, switch the shoes and put in the nots for the contrapositive. Number 17. If you play the tuba, then you play an instrument. Okay? If you play the tuba, then you play an instrument. All right? Converse, I'm going to switch the shoes. I'm going to switch these two statements. Once again, I'm basically switching the if and the then. So these guys will switch. So over here, this will become an if. If you play an instrument, that becomes a then. Then you play the tuba. Okay. Inverse, put in the nots. Okay, so leave it the way it is. I'm put in the knot. If you don't or do not play the tuba, then you do not or don't play an instrument. That's the inverse. Put in the knots. Okay. Contrapositive, I'm going to do both. Okay. Switch the shoes and put in the knots. So basically, once again, these guys switch. This becomes the then, and this becomes the if. So I'll start here with if you don't play an instrument, then you don't play the tuba. Okay. All right, truth values. We forgot to talk about the truth values. All right, converse. So if I switch the shoes, the original statement, if you play the tuba, then you play an instrument. If I switch those, if you play an instrument, then you play the tuba. Let me write these out for this one. If you play an instrument, then you play the tuba. Is that true? If you play an instrument, then you play the tuba. That's not true. I could play guitar, piano, violin, whatever. Okay, so that's false. So I would write, just come over here, I'll write false. I'll write guitar. Guitar is a counterexample, if they ask you what a counterexample is. All right, inverse is where I put in the knots. So I'll take my original conditional. If you do not play the tuba, then you do not play an instrument. Is that true or false? If you do not play the tuba, then you do not play an instrument. That's also false. If I don't play the tuba, I can still play the same counterexamples. So a lot of times the counterexamples for the converse will be the same counterexamples for the inverse. Again, I could play drums or whatever, so this one's false. I'll put drums. I could play the drums and I still play an instrument. Piano, cello, whatever. All right, contrapositive is where I switch the shoes and put in the knots. So going back to my original conditional, if you play the tuba, then you play an instrument. Contrapositive would be if you do not play an instrument, then you do not play the tuba. And that's true. Guys, the contrapositive is always true. If you don't play an instrument, that means you don't play anything. Nothing. So if you don't play anything, then of course you can't play the tuba. So that's true. I'm going to skip number 18, guys, just for sake of time. I think if you've got those first three, then just prevent having to write all that out. You should have a good handle on converse, inverse, and contrapositive. As always, you can check your solutions under quiz reviews on my website. Okay, the last several ones. This will be a pretty short video. Number 19. It says, determine whether each statement is a good definition. If not, explain. Okay, so remember, a good definition has to be using clearly understood terms. It's got to be precise and exact, and it's got to be reversible. So number 19 says, a newspaper has articles you read. Alright, let's check all the boxes. Clearly understood words, yep, everybody knows what all these words mean. Is it exact? A newspaper has articles you read. I say that's pretty exact. It's not using kind of, maybe, sort of. It's not using vague words or opinionated words. So yeah, that's pretty precise. But is it reversible? A newspaper has articles you read. I would say, if you reverse it, I would say, if it has articles you read, then it is a newspaper. And that's not true. I could have a magazine. I could have all kinds of stuff that have blogs. I could have all kinds of stuff that articles that that you read that's not a newspaper. Okay, so that's not a good definition. 20. A linear pair. A linear pair is a pair of adjacent angles whose non-common sides are opposite rays. Ooh, that's a mouthful. A linear pair is a pair of adjacent angles. Okay, adjacent angles. Angles that are right beside each other. Okay, adjacent angles whose non-common sides are opposite rays. So what is the common side? Well, the common side, if I have angle A and angle B, the common side would be this guy right here. Angle A and angle B are both sharing that line. The non-common sides would be, let's bust out the red here. That would be a non-common side, and that would be a non-common side. They don't share those. So the non-common sides are opposite rays, and that's correct. So this one would be a ray going that way, and this one would be a ray going that way. Okay, so that's true. So what about if so they're using clearly understood terms, everything is understood. That's pretty exact, okay, that's pretty precise, but can I flip it? Can I reverse it? A linear pair is a pair of adjacent angles whose non-common sides are opposite rays. If two angles have non-common sides that are opposite rays, so if two angles have non-common opposite rays, that means they have to share that, then they form a linear pair. Two angles have opposite rays. I'm trying to kind of model for you guys what your brain should be thinking. Of course, I know the answer to this immediately, but you should kind of be thinking this way. Okay, so draw a sketch, draw it out. Okay, so if two angles have opposite rays and they share that line, opposite rays mean they're going in completely different directions. Okay, these would not be opposite rays. Okay, so they have to be completely going in different directions. So I would say, yeah, that's true. That's true. Two rays in opposite directions, they have to add up to 180 degrees. They have to form a line. They are a linear pair. So yes, I would say this is true. Okay, 21. An angle is a geometric figure. Okay, yeah, that's pretty easily understood words. That's pretty exact. Is it reversible? A geometric figure is an angle. No, that's not true. That's false. And there are lots of counterexamples. Give me an example of a geometric figure that's not an angle. Square, line, circle. Line would be a good one. That's a geometric figure. That doesn't have an angle at all. Okay, so what about last couple here, and we'll wrap up. 22, write the following definition as a biconditional. Okay, now what is a biconditional? Remember, conditional is an if-then statement. I got to see the words if and then. Biconditional, I'll write this up here, biconditional has to have if and only if. Got to have that little magical phrase, okay? So 22 says an oxymoron is a phrase that contains contradictory terms. An oxymoron is a phrase that contains contradictory terms. So how can I throw in an if and only if? So we got the conclusion, we got the hypothesis. If an oxymoron is a phrase, then it contains contradictory terms. So basically the hypothesis is an oxymoron is a phrase. The conclusion is it contains contradictory terms. So I'm simply going to put the if and only if between the hypothesis and the conclusion. So I would write an oxymoron is a phrase, that's the hypothesis, and then the only way that can happen is if and only if it contains contradictory terms. Okay, last one. Write the following biconditional as two statements, a conditional and its converse. So this is the one where we're taking the biconditional, we're splitting it down into two separate conditionals. The regular conditional, and then switch the shoes, and we'll come up with the second conditional. So it has, I'll just kind of abbreviate here, two angles are complementary if and only if the sum, I'm just going to say measures 90 degrees. Okay, so here's the if and the only if. Okay, so remember when I'm breaking it down into two different conditionals, I'm going to eliminate the if and the only if. We're going to take that out. And then I'm simply going to, we're just going backwards. If they give you an if and a then to write a biconditional, we said, okay, let's eliminate the if and let's eliminate the then, and let's throw in the if and only if. But if we start with a biconditional, I'm working backwards. I'm taking out the if and only if, and I'm inserting an if, and I'm inserting a then. Okay, so conditional number one is going to be just what I put here. If two angles are complementary, meaning they add up to 90, and then I have the then. I'm just sticking in the then right here. Then the sum measures 90 degrees. Okay, that's conditional number one. Conditional number two is basically the converse of what I just wrote. So I'm going to take this statement, and now I'm going to switch these guys. So now this comes first, and then comes second. Okay, so I have, start here. If the sum measures 90 degrees, and then I come back up here, up to the top here, I put in the then. Then two angles are complementary. Alright, that's it for this video, guys. Hope you enjoyed that, and we will see you on the next video.